Good morning or good afternoon, everyone. My name is Vardan Amiri. I'm the Senior Sales Engineer here with Mimosa by Airspan, and we are going to go through a presentation with you all to cover point to multipoint. So the agenda for today is going to start off with why point to multipoint. So, what are the market potentials or deployment challenges? And then we'll work our way through to some of the solutions we offer, whether it's for a tower type deployment or high dense residential areas. And we'll take a look at some video surveillance applications. And then we'll go through a summary of all our product lines and Mimosa by Airspan family of products. So why point to multipoint? Well, point to multipoint wireless bridges the digital divide gap, resulting in economic, scholastic, vocational training, and medicine benefits, to name a few. It also enables underserved communities to keep pace with the global economy and for participation and competition in the modern world. So that's one of the main reasons why we need it. But that doesn't come with, without any challenges. So there's some challenges there, as far as distance goes. We have, longer range distances to, customers being far away from, any fiber or available copper. The capacity requirements. Today, a lot of customers are underserved and hardly get even 5 megabits per second. The reliability may be questioned. There's a lot of noise in the environment. As you know, 5 gigs is used in home Wi-Fi's and by other fixed wireless access products. And the other thing is, well, there's a cost to this, and it's at the end of the day, it's a business, and everybody needs to make a buck. So what kind of products or solutions do you deploy to be able to address a wider customer base, to be able to shrink that total cost of ownership? Now, there is a huge potential out there, whether it's the rural, suburban, or urban. As you can see from the study here, you have 1.5 billion in the rural areas for wireless ISPs and 10 billion plus for the suburban and urban. So we'll go through basically, the type of solutions we have for basically all these cases or scenarios. So how do we address that? So obviously, fixed wireless access to the rescue using Mimosa by Airspan products. So here's a slide that basically provides a nice picture of what we provide and offer today. We have backhaul products that can actually help, backhaul larger capacities or help you go deeper into residential neighborhoods, where you can tap off a point to multipoint device off there and then basically serve multiple clients. And then the clients would basically be powered through a PoE injector. And we'll also have an Ethernet or network interface to the customer's network, which would connect to a switch or typically to a Wi-Fi router that's in their homes. Maybe one or multiple Wi-Fi routers. It just depends on the size of the home. The point-to-point would be connected to a fiber network ultimately, and then this entire Mimosa by Airspan solution of products would be managed or may be managed through the Mimosa Cloud. Mimosa Cloud is an option. It's not mandatory. You can enable or disable that service, but it allows you to manage basically every single Mimosa by Airspan product. In today's wireless world, to be able to provide the capacities that are required by customers and the reliability, there's several technologies that are required to be in products to be able to do that. One of them is MIMO, so multiple in, multiple out. We use MIMO for 2 cases. We use it to basically enable beamforming, so increases the power by 3 dB, so improving the link budget. We also use MIMO for increased capacity. So we basically send multiple streams of data to the same client to increase the capacity in a deployment. Now that we have this high capacity, high link budget network, we use something called a TDMA protocol. So what we do with TDMA, we slot everything accordingly, so time division multiple access. What does this allow us to do is to use the spectrum a lot more efficiently. So it reduces the collisions drastically, thus making the wireless very efficient. Now that we have a TDMA protocol using the wireless efficiently with all this MIMO technology, we have GPS built into our product, allowing us to sync basically a network-wide deployment. Thus, we time the transmission of every access point and the reception from every client, thus allowing us to reuse the same spectrum in areas where it may be congested or not, but allowing us to squeeze as much as capacity as we can out of a single or double or dual channels. Once you have all this, we have a single pane window, which we call the cloud. You can always log into the cloud from wherever you like, and you can go ahead and manage your entire network and look at performance numbers. Now, what we typically do is we don't just build wireless products. We build wireless products for different deployment scenarios or for different use cases. So we have products that basically are used to deploy in rural areas. We have products that are designed to be deployed in suburban areas. So rural areas, basically, homes that are basically spaced out quite a bit from one another. You have the suburban area where it's a high dense residential home environment. You have the urban where you can do kind of point-to-point links and a hub or spoke type deployment using, building rooftops and providing high capacity to multiple tenant or dwelling units. And then we have the smart city where you can have basically Wi-Fi backhaul, video surveillance, meter reading, etc., so on and so forth. So we build products for the appropriate deployment scenario. Here's an example of what we refer to as a MicroPop. So a MicroPop typically is deployed in a high residential area where you would deploy the access point basically in the middle of the neighborhood on a telephone pole or maybe a rooftop of a building. And then the clients or the CPEs would basically be deployed at the same height and basically connected to the access point. Typically in this scenario, clients would be roughly about 1,500 feet to 2,000 feet away from the access point. So it's not so much about the coverage, but it's about basically capacity. Typically in a high residential area, you would run out of capacity within maybe 1,500 to 2,000 feet as you're providing 25 megabits minimum all the way up to 200 megabits per second services. We have the other application, which is long-range architecture. Now, this is more of your traditional deployment where you have a radio connected to an antenna, which is mounted on a tower or a grain elevator or a water tower, and basically covering a geographical sector. And then you would have the CPEs or clients deployed on top of building rooftops or wherever, and basically connecting back to the access point and taking advantage of the high capacity that is available. And you'll see later on we have a few flavors of these clients and antennas that you can use and access points for these type of deployments. So if we take a deeper dive into the rural deployment scenario, so looking at sectorized towers type deployment. So here's what you have in terms of products for deploying on a tower. We have basically two flavors of antennas and as well two access points. So we have the N545x2, which is a 2-port antenna. It's a great antenna, provides 45 degrees of coverage. It provides basically a 43 dB front to back isolation, giving you the performance of a horn, but the coverage of a sector antenna. As you can see, the antenna covers anywhere from 4.9 all the way to 6.4 gigahertz. We have the N545x4. This is a 4-port antenna, so basically capable of doing beamforming. The specs are identical to the N545x2, but you have 4 panels in there. It also has a 43 dB front to back isolation and a 2-degree electrical down tilt. So when mounted at 0 degrees, it's actually pointing down 2 degrees. And it's got dual slant plus or minus 45 as well. Now, the devices that connect to these antennas, we have the A5C, which is a connectorized 4x4 access point. So you can connect that to a N545x4 and take advantage of the beamforming. Or you may choose to connect 2 N545x2s on the A5C and cover 2 separate geographical areas. So you point them in opposite direction or side by side to do a 90-degree coverage. We have another solution, which is the A5X, which is a access point. It's a 2x2. You can connect the 2x2 access point directly to the N545x2 and basically provide high capacity to that coverage area. The other option you have is if you need more capacity at a given site, you may use the N545x4 and basically connect 2 A5X access points to that N545x4, thus doubling the capacity using 2 access points with a single antenna. So here's an example of a rural telco, which is called Niemont. They mainly deploy in northeastern Montana. Basically, they typically deploy on all their towers. They have roughly 73 towers. They mount typically the Mimosa access points in 6-sector configuration. They use KP performance antennas to do this. They basically, were looking at offering services of 25 megs down and 3 megs up. During the trial, we were able to show speeds of anywhere from 200 to 330 megabits, depending on the distance from the tower. And basically, we went as far as 9.89 miles, and that is where the 200 megabit service was delivered. So, typically 6-sector configuration using 60-degree antennas, providing 360-degree coverage from a single tower. And they typically deploy these roughly anywhere at about 150 feet or above on a given tower, depending on the type of tower they have. Here's one of their towers where they deployed our units. They typically configure everything at the bottom and hoist it onto the tower and attach it to the tower. The middle picture shows you our access point using jumper cables, RF 50 ohm jumper cables connecting to the KP performance antenna. And the picture on the right is basically using our client, which you will see it's the little bump on the J mount, and it's connected to a 27 dBi KP performance dish. So that was the unit that was at 9.89 miles away from the tower. You may basically have various configurations for your rural deployment when mounting on towers or grain elevators or water towers. You may choose to use 45-degree antenna. Mimosa by Airspan actually manufactures the 45-degree antennas. You may also choose third-party antennas that enable 60 or 90-degree coverages. Ensure that you always, mount the A5C on a 4-port antenna. You may also mount a 360-degree antenna onto the A5C, basically providing 360-degree coverage for MicroPop type deployments or in areas where you have very few homes that require high capacity, where it's really not so much dense, but they're basically spaced out quite a bit, the customers. So more of the rural deployments. But you may reuse frequencies because of our network-wide synchronization. You may go ahead and reuse frequencies on opposite sectors. Using the Mimosa by Airspan antennas, remember you get a 43 dB front-to-back isolation, so giving you the best performance and modulation in that given sector. If you need extremely high capacity at a given tower, you may deploy 8 sectors using the Mimosa by Airspan N545 by 4. This will give you basically beamforming as they're 4-port antennas. They're each 45 degrees. That's all 8 of them giving you a 360-degree coverage. And you're going to basically be able to hit roughly 5.6 gigs peak of user traffic in this configuration from that tower. The antennas, again, they provide great side lobe suppression. The antenna gains are 19 dBi, and they also give you an additional 3 dB gain because of beamforming, so resulting in a total of 22 dB of gain from the antenna, and provide you the extended frequency anywhere from 4.9 all the way to 6.4. Again, giving you the performance of a horn, but the coverage of a sector antenna. So if we do a deeper dive into providing point-to-multipoint access in suburban, urban type deployments, so we refer to those as MicroPops. So here are the devices that we offer for MicroPop type deployments. So we have the A5, which is an access point that has a built-in antenna. It has 4 90-degree circular polarized antennas. Again, like I mentioned, typically mounted on a telephone pole or on a residential rooftop. Clients are mounted roughly at the same height. And it's not so much, again, about the coverage. It's more about providing high capacity to that area. So we typically recommend, 1,500 to 2,000 feet type radiuses. Another option would be using the A5C access point and connecting it to the N5360 antenna, which basically gives you a 15 dBi gain, including the beamforming. Now, this enables you to go a little bit further. So instead of the 1,500 to 2,000 feet radius, this will allow you to go, up to about, 2,500 feet or 3,000 feet radius. Now, keeping that in mind, we do have customers that have gone a lot further with this. I've seen customers go as far as 4 miles. If the RF propagation allows, you may certainly do so, but the product was designed more for the smaller radius. But you may always take these products out of their comfort zone, and you notice that they'll perform as expected. The N5360 is linear polarized, thus ensures 2 equal MCS streams per client, and obviously has the beamforming gain, enabling 4 streams. So the question you may have is, well, why would I choose one over the other? So A5 is more of a discrete solution. So pretty much you want to kind of hide it somewhere, maybe on a telephone pole or behind, in the center of a building where people can't see it. So mainly intended for discrete deployment, smaller radius, completely fully integrated unit. All you need is a Cat6 cable to backhaul and power the unit, where the A5C and the N5360 gives you roughly about 40% more coverage. But remember, it's basically requires more space on a pole. It's a 2-unit solution and requires jumper cables to connect the A5C to the N5360. Now, anytime you purchase any of the Mimosa antennas, please note that the jumper cables are included in the box. So no need to order those separately, whether it's the N5360 or the N545 by 4 or the N545 by 2, the jumper cables are in the box. So what is the business case for MicroPops? So some of the competition is, fiber, of course, which, is very expensive. Fiber can cost anywhere from $1K to $2 or $3K, depending if it's, urban or suburban type, fiber rollout. And especially in some of these rural areas where the distances are very far from the tower, you're talking about 15 to 20 miles before you can actually hit a house with fiber. So very costly. And typically when you deploy LTE type solutions, depending on the spectrum, that may be costly as well. So the benefit of deploying MicroPops is the return on investment is very short. You're looking at roughly $200 to $300 of capex per household. Typically, the ROI is within 6 months at a $50 per month, plan charge, and it's very fast to deploy in a neighborhood. So you can quickly install, several customers in a day by a single installer. Just came back from a trip from a customer who's mainly MicroPop type deployments, and they typically have an ROI within 3 to 4 months. And they're capable of deploying anywhere from 6 to 8 clients per day. So here's an example of what Mimosa by Airspan has to offer. So some of the technology that is built into our product, which is GPS, that allows us to synchronize network-wide, TDMA protocol, the antennas. So basically, what does that all mean to you? If you look at the picture on the left-hand side, here's a deployment using MicroPops, so smaller cell radiuses. Now, typically in this deployment, if there's no synchronization, what happens is access points, transmit and receive at different times. Thus, when this happens, they interfere with one another as they are very close, and then basically result into high bit error rates, low SNRs, thus basically causing the modulation to drop. Thus, performance is degraded. Therefore, based on the performance now that is available, because of all that, they can reach roughly about 250 subscribers. They can't provide more than 25 megabits of services due to basically the capacity that's available, and they end up using the entire 5 gig spectrum. So UNNI 1, UNNI 2, UNNI 2 extended, and UNNI 3. Same deployment, looking at the right-hand side picture, enabling the SRS feature and synchronization and TDMA within the Mimosa by Airspan products. Now what happens is the entire network is synchronized. They're able to transmit and receive all at the same time, thus basically improving the SNR, packet error rates drop, thus the modulation adapts to a higher level, thus increasing the capacity and being able to reach 750 subscribers based on capacity. This service provider is able to provide up to 200 megabits of services to customers or clients who need it. All this using 2 80 megahertz channel, this using a total of 160 megahertz of spectrum, as they are reusing the same 80 megahertz channel across different access points. So this is the innovation that Mimosa by Airspan brings to the table. Here's an example of a MicroPop deployment off a utility pole. This is in Minneapolis, Minnesota. As you can see, the height of where it's installed, typically this would be a high residential area, whether it's in these small towns and rural areas where you have the main streets, where you have a high density, or this would be in a suburban area as well. But you notice the height, it's roughly just above the roof line of the homes, and the clients would be roughly deployed at the roof lines as well. Here's a MicroPop deployment. This is from one of our customers, Prairie Hills Wireless. They are in Nebraska. They're very well known for deploying MicroPops on customers' rooftops by providing them free internet access and basically providing coverage to the neighboring homes around there. They typically have anywhere from 15 to 30 or 35 clients per access point. Now, you may use basically the Mimosa by Airspan solutions in point to point, but using it for an application which we call video surveillance in smart cities. So you can deploy the product such that you can go ahead and backhaul video traffic to the access point and onto your core network. Again, very similar example or deployment architecture. You may use any one of our access points and antennas. In this scenario, you see the A5X being connected to the N545x2, connected to the Mimosa by Airspan client, and then the clients would have a camera connected to each one. So basically, for the video surveillance application, you would backhaul all this traffic in the upstream off to your core network and manage in the cloud if you'd like. Here's a typical deployment scenario of a customer. So basically, providing a cost-effective solution for backhauling all the video data. You notice the little NEMA enclosure with a video camera on the box and with a Mimosa by Airspan client backhauling that traffic. Depending on the type of compression and video cameras you use, the number of clients per access point will be limited to that amount. So in this case, we give you an example of you can have roughly 40 UHD 4K cameras connected at 30 frames per second backhauled by the AP. This enables quick deployments, provides you low latency and jitter, and basically very cost-effective, high-performing solution. Now we'll take a look at the Mimosa by Airspan clients. So we have two main flavors of our clients. What we have is we have the C5C, which is a connectorized client. Allows you to attach your antenna of choice using basically the RPSMA connectors on the unit. Typically, you would use this solution if you need an antenna gain greater than 25 dBi. So if you want to go to 30 or 35 or greater dBi, you would choose the C5C connectorized client. Typically, you would do that to basically get longer range. The antenna, the radio or the client gets its synchronization from the access point. We have the C5X family of products for multi-point clients as well. It is a radio with a twist-on antenna. We have multiple flavors of antennas that you can twist on. You have a 12 dBi horn, a 16 dBi horn, a 20 dBi dish, or a 25 dBi dish. So anything up to about 25 dBi, you may choose the C5X along with an antenna of choice. Again, the C5X gets its timing and synchronization from the access point. Both these units, similar to the access points, can work anywhere from 4.9 all the way to 6.4 gigahertz and support spectrum reuse or synchronization. So flexible antenna options or flexible external antenna option of your choice. Here is the typical distance relationship with respect to the access point and using the proper antenna on the client. So if we look at the picture above, whether it's an A5 or an A5C with an N5360 for MicroPop deployments. Remember, we mentioned those are typically short distances. So depending on the configuration, whether it's A5 or A5C with N5360, you would go up to maybe 2,500 or 3,000 feet. If you typically have line of sight, you would use a 20 dBi antenna, and if you have some branches or a small bush in the way, you can use the 25 dBi antenna and just twist it onto the C5X. If you're doing tower type deployments, grain elevator deployments, or water tower, depending on the distance you are from that tower, you can basically choose the appropriate antenna. Again, we offer anywhere from 12 all the way to 25 dBi. If you need anything more than that, whether it's 30 or 35 dBi, you may choose to deploy the C5C using a third-party external antenna. Just make sure you get the appropriate jumper cables to connect basically the antenna to the RPSMA connectors on the C5C. So some of the Mimosa by Airspan portfolio of products. So we provide a wide range of family of products, whether it's access points, backhauls, clients, antennas. On the access points, we saw the three flavors, whether it was the A5, A5C, or A5X, but we also have backhaul products. So if you need to backhaul any one of these access points, or you need to provide high capacity for enterprise type applications or urban type deployments for hub and spoke type deployments for multiple tenant or dwelling units, you may always choose our backhaul products. We have solutions in the 24 gig, 11 gig, which is licensed. We have connectorized and integrated 5 gigahertz. Connectorized is the B5C and all integrated is the B5. And our clients for the point to multipoint are dual purpose. So, with your configuration, you choose a configuration, you may use any two units, C5X or C5C, to behave as a point-to-point link, providing you over 700 megabits of capacity between the two sites. The clients are also used as clients for point-to-multipoint. And on the antenna, we have access point antennas. We have a 360-degree coverage antenna. It's not an Omni. It's actually 480-degree antennas in the N5360, shifted by 90 degrees. We have the N545 by 2 and the N545 by 4. The antennas that connect to the C5X client are the 12 dBi, 16 dBi, both of those are horns, and we have a 20 and a 25 dBi dish as well. Again, we have the network management system, which is a cloud-based management system, and we have a network design tool that allows you to design your network to get a good idea of what the performance you should expect before going into deployment. We also support additional management features if you like to use SNMP, syslog, or REST APIs. Those are still available as well if you choose not to use the Mimosa Cloud. We also have HTTP and HTTPS directly to the unit. So here's some network designs and implementation. So when you use the network design tool, here's a good screenshot. This is an example of a point-to-multipoint A5C with an N545 by 4. The location is basically Las Vegas, Nevada. You have the height of the AP, which is the antenna. You have the height of the clients, or typical height of the clients, antenna headings, and if any down tilt. So it gives you a nice coverage area for basically MCS 7 or higher. And if you look at the legend at the bottom left-hand corner of the map, you will notice the antenna gain required to achieve MCS 7 or higher. And this assumes obviously a 8 dB noise as well. So if you look at the deployment details, it says environment rural 8 dB of noise. You can basically change that. You can even make it 0 if required. And you have some of the parameters that you can fill in, and basically on the antenna side, as well as TX power and channel width, as well as center frequency. Here's a typical subscriber install best practices. So typically, here's an example with the C5X with an N5 by 20 antenna screwed onto it. It's using a flexi mount. You may choose to use flexi or J mount. This example shows you with a flexi mount. You have a single Cat6 outdoor rated shielded cable with shielded connectors that comes down, goes into a gigabit NID, which is a search protector, and then goes on into the house. Make sure you ground both the NID as well as the Mimosa by Airspan client. Now, that cable that comes into the house, you may connect it to a Mimosa PoE, which will power the unit, as well as give you a Ethernet cable out to connect to the customer's Wi-Fi router. Or if the customer's Wi-Fi router is PoE capable, you may also power the unit using that same Wi-Fi gateway. To make life easier for installers, we've also come up with a install app. So basically, the install app is available for both Android as well as Apple iOS. It's a powerful tool. It allows you to basically configure everything off the install app step by step. You may also choose to automate that whole functionality. As our access points support radius authentication and provisioning. So everything can be done through the radius server, which is on your network. It's used for both C5X and C5C installing and aligning. It's got an audible aim, and basically, again, you can make this as easy as for the installer as possible by using radius, and all they have to do is just run the cable, install and align, or you can make it as complicated as you like, where they have to enter IP addresses, VLANs, and all that other kind of stuff. Now, this install app is supported through a gateway that's required. The network management system, our cloud-based, basically allows you to manage and monitor your entire network or Mimosa by Airspan network. Since we have GPS built into the product, they will actually plot them on the map accordingly. You'd be able to look at the spectrum of the environment per access point. You can look at performance, whether it's RF data or it is basically throughput or capacities used by each customer or by the access point, whether it's upstream or downstream. So very user-friendly. You can also upgrade your entire network to a later software. Once new software becomes released, you can basically do that through the cloud management system as well. In summary, so what I'd like to leave you with is, the reason why people choose Mimosa is, we provide the best, one of the highest price for performance products that is out there today. The product is also easy to deploy. We have a lot of cool features to mitigate and combat interference, whether it's from a software perspective or, our antenna designs, which allow to, mitigate interference. Our low power consumptions, for example, our A5X, doesn't consume more than 13 watts of power. So very low power consumption. Thus, you can use batteries to maintain the links while power may be off in that neighborhood. Wide frequency ranges, quick ROI. Like I mentioned, I was with a customer last week. Their ROI was 3 months. Very user-friendly graphical user interfaces, whether it's HTTP or through the cloud, and we provide very high reliable links, whether it's our access points or clients or point-to-point solutions. So you can always reach out to us and stay in touch, whether it's Twitter, LinkedIn, Facebook, or YouTube. We have tremendous amount of videos on YouTube on how-tos and basically product descriptions or podcasts. You may always go there and basically look at some of the YouTubes we have available. So please stay in touch. You may always reach us directly or through Streakwave. So I'd like to thank you for your time and hope this was beneficial to you. And we hope that you deploy or continue to deploy Mimosa by Airspan products.
Great, thanks, Martin. We're opening it up for questions right now. So there were a few questions that were coming in while you were doing the presentation, so I'm going to go ahead and ask them. Will you be making another device after the A5X?
What was that? I didn't hear you.
The question is, will you be making another device after the A5X?
Oh, definitely. So for those of you who have deployed Mimosa, as you notice, we've been evolving over time. So we're always deploying or designing newer and coming out with newer products and solutions, including new standards as well. A lot of our products today are based on the AC. With the AX standard, we will eventually gradually move towards using the AX technology in our future products. So definitely that is what we do. That's our lifeline. So always coming up with new products.
Great. The next question we have, they're asking, it seems everyone is in the race to replace the 5G with 60 gigahertz, and we have already begun using 60 and plan to remove all of our 5 gigahertz soon. Will you be releasing your 60 gigahertz soon?
So we don't in the immediate future, we don't have 60 gigahertz solutions. 60 gigahertz is great for point to multipoint, but you have to keep in mind that, 60 gigahertz has a lot of oxygen absorption and rain fade. So the distances drastically drop, and typically the cost is slightly more for 60 gigahertz. Again, great solution, but it limits the distance based on oxygen as well as rain fade.
And then they're asking, are there plans to use the 60 gigahertz range, or is that basically what you just talked about?
No, we don't have 60 gigahertz. Our solution for that is using the 5 gigahertz, providing high capacity to homes. Remember, our 5 gigahertz MicroPop solution would be your equivalent to the 60 gig shorter range, except we can go much further, and we can provide up to 350 megabits per client in the downstream, plus another 350 megabits in the upstream. So we can provide those high capacities without going to the higher cost 60 gig solution.
All right, awesome. Here's another question. They're saying, hi, Mimosa team. Really love what the A5X is going to bring to the table. If I have an N5 45x4 or N5-360 antenna deployed, can I hook two A5X radios up to this?
On the N5 45x4, yes, you may connect two A5Xs to double the capacity at that location. Having said that, on the N5 360, that would not be possible because of the way the antennas are in the 360. You would need to connect the A5 360 to an A5C only.
Okay, and we'll have time for one more question here. With the introduction to Wi-Fi AX standards, will Mimosa be doing anything with AX anytime soon?
Oh, yes. So obviously that's what we're going to evolve to. So some of our next generation products will be based on the AX standard. So please keep tuned.
Awesome. Well, thank you, Varden, for doing the presentation, and thank you for everyone that joined in today. As I mentioned earlier, the webinar is recorded, so we will make sure to send that out to everybody sooner than later. And actually, one more question just came through. They're asking, will you be releasing new firmware to upgrade to AX or new devices?
Yes, so we will have, once the AX platform becomes available, there will actually be firmware for those devices. So, we continue to upgrade. So we are currently working on AX platforms. They'll hopefully be available next year, and there'll be firmware that goes along with that.
All right. Questions are still coming in, so we'll have time to answer these last two. How many client max do you recommend for each AP?
It really, client max, so the hard limit in SRS mode, which is GPS sync, is 44 clients, but it really depends on your oversubscription rate and the type of packages you want to provide customers. So I've seen as much as 37 in an actual deployment. I just came back from a trip. They say typically when we hit 30 or 35, it's time to deploy another access point. It really depends on the capacity and the packages you offer your customers and your oversubscription rate. We don't have a customer that's hit the max that's 44 thus far, because they run out of capacity before they hit the actual hard limit.
All right. Well, that's all the time we have. Thank you all for the questions. And again, thank you, Varden and Mimosa team, for helping out and doing the presentation. As always, if there's any questions, please reach out to Streamlining and Mimosa, and we'll be glad to help answer anything. Any last-minute things that you wanted to add, Varden?
No, I just want to thank everyone for taking the time out of their busy schedule to join and learn more about Mimosa by Airspan point-to-multipoint solutions.
Awesome. Thank you, everyone. Have a great day.
All right.